Hello, welcome back. This is Jeffrey, and the topic we're going to be discussing today is rates of change and behavior of graphs. Here's the learning objectives. In this section, you'll learn to find the average rate of change of the function. Use the graph to determine where a function is increasing, decreasing, or constant. Also, using the graph to locate the local maximum, local minimum, absolute maximum, and absolute minimum. Alright, so let's start off with finding the average rate of change of the function. So using only the beginning and the ending data, we'll be able to find the average rate of change over the specified period of time. To find the average rate of change, we divide the change in output value by the change in input value. So here's the equation for finding the average rate of change. We have change in output on top over change in input. Another word for change in output is delta y, which delta signifies the change in the quantity. We read the ratio as delta y over delta x, or the change in y divided by the change in x. Change in y is simply just like the second point of y value minus the first point of y value over the second x value minus the first x value. So that's how you find the average rate of change of the function. Here's an example of finding the average rate of change of the function. So the gasoline price increased by $1.37 from 2005 to 2012. Over 7 years, the average rate of change of the gasoline price is delta y over delta x. So in this case, the input is how many years? So 7 years. And the output is change in dollars, so 1.37. So it's approximately $0.196 per year. And that's how you calculate the average rate of change. So you first calculate the y difference, and then you calculate the x difference, and then you simply put that find that ratio. The next topic we're going to be discussing is using the graph to determine where a function is increasing, decreasing, or constant. So here are some few terms that you will need to learn. So first is increasing and decreasing. A function is increasing where f of b is greater than f of a. If f of b is greater than f of a, where b is greater than a, like this. So this point right here is negative 4 comma negative 16. So in this case, f of b will be 16, and f of a will be negative 16, where we know that 16 is greater than negative 16, and also b is greater than a because negative 2 is greater than negative 4. So we know that is part of the function is increasing, indeed, because that's what this equation says, like this explanation says. And it's basically the opposite for decreasing. So we know a function is decreasing where f of b is less than f of a, where b is still greater than a, like this, for example. So we know that f of b is less than f of a. So f of b negative 16 is less than 16. Yes. Where b is greater than a. So 2, yes, 2 is greater than negative 2. So we know that this part of the function is decreasing. You have some other few terms that you'll need to know. Local maxima or local maximum. So maxima is the plural form of maximum. So when a function changes from increasing to decreasing, that's local maximum. When a function changes from decreasing to increasing, that's local minimum or minima. And together, local maxima and local minima are called local extrema, or local extreme values of the function. So here's an example that we can take a look at. So this part of the function is increasing because f of b is greater than f of a, yes, and b is greater than a. And this part of the function is decreasing because f of c is less than f of b, right? And c is still greater than b, so this part of the function is decreasing. And here, this is this point b comma f of b is a local maxima. Why? Because it changes from increasing to decreasing. That's what being said here. Function changes from increasing to decreasing. That's the local maximum. So this is the local maximum of this function. The last one is using the graph to locate the absolute maximum and the absolute minimum. So the y-coordinates output at the highest and the lowest points are called the absolute maximum and the absolute minimum. So basically, just look for the highest and the lowest point of a graph. Let's take a look at here. The highest point of this graph is obviously this, right, 2, 2, so that's the absolute maximum. And the lowest point in this graph is going to be here, 0, -2. So that's the absolute minimum of this graph, right? Yeah, just know these. And let's do some practice questions. First, identify the intervals at which the function appears to be increasing. So find, like, on which interval are this function increasing? Is this function increasing? I think there's gonna be 2 of them, so you should have 2 for your answers. Now I'll give you guys 30 seconds to work on this, starting from now. Alright, so this should be your answer. In interval notation, we would say that the function appears to be increasing on the interval 1, 3, right? 1, 3, this part is increasing, and also this part 4, to infinity, because it's an arrow, we don't know where it ends, so we just write infinity for this one. Second practice question, find all the local maxima and minima for this function. Again, I'll give you guys 30 seconds to work on this, starting from now. Alright, so the answer for this one is here. So the local maximum is the y-coordinate at x is equal to 1, which is 2, right? X is equal to 1, where it's 2, because it's where increasing function becomes a decreasing function. So that's the turning point. So this is the local maximum. And whereas the local minimum is the y-coordinate at x is equal to -1, which is -2. Right, because this is where the decreasing function changes to increasing function. Alright, last practice question. Find all the absolute maxima and minimum for this function. Again, 30 seconds starting from now. Alright, so here's the answer. The absolute maximum is the y-coordinate at x is equal to -2, and x is equal to 2, which is 16, right? Because they are both the highest points of this function. And absolute minimum is y-coordinate at x is equal to 3, which is -10, right? This part. This is the lowest point on for this entire function. So, alright, and that's it for today. Thank you.